Hello, everyone. This is Dr. Dax. Welcome back to class. We are in week 5 of your web analytics course, and we are entering session 2. So today we're on our second session for the class. If you haven't done the first session for week 5, I encourage you to go back and catch that. And today we are going to be talking about some really interesting things in what we call discrete modeling in data analytics, which will tie into your potential career in web analytics or whatever you seek to go into as you study this course and move toward your degree completion in computer science or data science and whatever your focus happens to be. I'm glad you're here. I hope you guys are having a good week. And without further ado, let's go ahead and get started. I want to talk about our objectives for today. First of all, we're going to cover some benefits of web analytics, and we're going to discover the changing role of statistics and insights. We're going to tie it all together by discovering the changing role of statistics and insights in what we do, and we'll discuss the career landscape and see how to strategically position ourselves for the greatest impact. And so my goals for you today are pretty simple. I want you to be able to explain the benefits of business analytics and understand the insights and the changing roles of what we do. You'll be able to comprehend communication preferences and examine the business intelligence job outlook. In addition to that, we're going to be looking at discrete analytics model, and I'll explain more about that in just a little bit. But first, let's take an overview of business analytics because it all ties together with what we're studying here. We've been hitting on some specific concepts within web analytics as it pertains to dashboards and page logging and things that speak specifically to web tracking and using that information within your company. But understand that data science, web analytics, statistics, marketing, all that ties together as all that stuff converges, and we need to be fluent in all these topics. And so, as we talk about business analytics, what we're interested in is understanding how we can quantify the effects of change with that information. We are interested in taking this information here that we're gathering up with all this data and providing evidence for interested parties to act. We want to improve and optimize market strategies using business analytics because it's all connected, as I said. We're going to identify relevant facts for decision support, and we want to provide a competitive edge for your organization. So, the changing role of insights, it was affected by different things. The first and most profound impact has been the rise of what we call big data. Now, we've talked about that in the first week, and I want to revisit that. Just remember that there's a mountain of information out there being generated every day. And with that advent of huge information, it's kind of the new oil. And companies that can take advantage of that are the ones that can remain competitive and stay on the forefront of change in the 21st century. If you can evolve and stay on top of that and leverage the technology that's available, you can remain competitive, particularly with high performance computing. So statistics itself is not new. Marketing is not new. We are now, as a culture and as an educational institution in general terms, appreciating the conglomeration of these disciplines, we'll call it, as they sort of meet in the middle and understand that these algorithms and high complexity ideas are only possible with high performance computing. Very few people are capable of doing a lot of that stuff. But when we're dealing with really large data sets, even the best mathematicians are fundamentally useless. You need the right resources and the right computing power. But it's also important to have the right knowledge to be able to operate those algorithms and design the machine learning models. And it's important to understand the role of decision management. Today, it's evolving along with the technology because today it's important to understand that the decision makers are more and more appreciative of the changing insights of data science and how important it is and how volatile it is. So let's talk a little bit about the value of business analytics. What we do is we first of all define the value. And it's important to not only know what the value is and be able to understand it, but we need to communicate it in a way that makes sense to interested parties. So you want to put a value on the data in terms of dollars, savings, resources, whatever pertains to the situation. Now, we're speaking in broad umbrella terms right now, but that's okay because we're interested in being able to not only understand the information and perform these calculations, but communicate them, usually through some visual medium. And that helps us to deliver the value. Additionally, we want to measure the value. Now, the measures of the value can take form of different ways. You can measure it in terms of, like we said before, cost savings. You can put a dollar figure on it. You can measure it in terms of percents, some type of an improvement, some sort of other metric, whatever the benchmark happens to be for that situation, we can put a value on it that puts the data on the same page as the parties can understand it. And while we're talking about communicating the value, let's talk a little bit about the communication preferences. So, as we discuss the communication preferences, we need to understand the 4 different types. First of all, we have the analytical perspective. Some people primarily care about just the facts. So it's not surprising that most people work in business analytics who are highly in favor of this perspective. Business analytics professionals tend to like logic, rigor, and taking what I would call a rational perspective. People who prefer to communicate using this perspective tend to focus most on the value, the outcomes, and other tangible measures. They'll often willingly have an argument, not because they dislike the concept or they dislike other people, but they're often simply seeking the truth. Whatever they see as the truth, that's the ultimate goal. And they can be interpreted as cold or sort of unemotional, but it's not personal. Nothing is personal for them. It's just, if you've ever watched Star Trek, they're kind of the Vulcans of the organization. All right, so moving down to the bottom left quadrant, let's talk about the process perspective. Now, in this type of a communication preference, these people primarily care about the steps that are needed to achieve the outcomes. They're more interested in process than the product. And rather than justifying or focusing on the justifications, they tend to be more interested in the how of how things are delivered. They may be equally interested in detail, but it's simply a different type of detail. So the employees who prefer this form of communication tend to use this perspective to focus on the quality, governance, and of course the process. So they will often be interested in understanding and communicating the how of how things are going to happen, how the changes occur, and how the change will be managed. And catering to this kind of a perspective involves focusing on the execution and planning. And a major concern for these type of people is managing risk. So that's something to keep in mind. All right, so let's move to the bottom right quadrant and discuss the personal perspective for just a second. There are some who focus on how the change will impact the people. And they're interested in the positive or negative outcomes. And while everybody needs to be able to demonstrate what we call tangible benefits in some form, they may also be as well interested in understanding the intangible personal benefits associated with initiatives like job satisfaction, uh, internal exposure, external exposure, uh, job performance, that kind of thing. So understand that people who prefer this type of communication tend to focus most on intrinsic ideas like trust, interpersonal relationships, communication, collaboration. They may decide not to support a change, not because they think it's a bad idea, but simply because they perceive it as something that could hurt their team. They put the team above the idea or the end result. They cater more to this perspective if it involves focusing on the team's interests and how their careers and other careers might be developed or impacted for better or for worse. People in HR tend to gravitate toward this kind of a perspective. And last but certainly not least, in the upper right quadrant, we have the strategic perspective. So some people are very interested in the strategic implementation. And the implications here are like this. They are interested in through maybe through competitive differentiation, long-term vision, strategic transformation, these kind of concepts. Without the ability to describe what we would call a bigger vision, these types of people might actually be resistant to change simply because they feel that there could be better options elsewhere. Individuals who prefer to communicate using this perspective tend to focus most on strategy, which is not surprising, and other abstract concepts, and they like to simplify details. They're more big picture individuals. They're interested in what we would call conceptual linkages and visual representation of complex ideas. They don't like to get into the minutia of what's going on, but rather they would be more interested in the overview. Catering to individuals who focus on this kind of perspective means that you would need to think less about structured methods of communication and more on transformative outcomes and placing an emphasis on that if you want to win their support. So, those are just four generalizations of the communication perspective. So, generally speaking, everyone does not necessarily fit in a box. These are not mutually exclusive. You might be someone who can actually identify with one or more quadrant of the communication preferences. I am probably both the first and second, the analytical and the process uh, bound, but there's no right or wrong methodology. And kind of like the personality test or any of those things, it's not perfect and it's not the end all be all. If you look at something one way and you feel like you're labeled as, say, for a strategic perspective person, next week you might be gauged a different way. And that's all right. Just understand how to look at these different perspectives and show empathy in order to communicate the ideas better. Because as a data scientist or web analyst or whatever job field you go into, it's important to try to listen to the other individuals and understand where they're coming from and understand their perspective in order to communicate the ideas more effectively. All right. So moving on, let's go to a little bit of a case study here. Now, I am in education, obviously, but this is a part-time job for me. I have an actual day job that is in telecom, and so this case study speaks to me. This is my actual wheelhouse. This is the one that pays the bills. So uh, I wanted to pull this and share it with you, and I hope that you find it useful to kind of illustrate some ideas. Let's talk a little bit about customer retention. Most telecom companies see the majority of their revenue come from retail. And customers tend to pay through one of two payment structures. They pay through subscription revenue or usage revenue. Now, subscription revenue, which we often refer to as postpaid plans, mean that there are minimum payments that are fixed and payable on a set schedule and are capped on consumption level, and there's a pre-agreed usage rate, and then there's the usage revenue, often referred to as prepaid plans, where payment is made ahead of time and the consumer is based on a pre-agreed rate, and once it runs out they just pay for some more. So the split between these varies by geography, and we're interested in a couple of ideas we're going to talk about here: customer retention, network analysis. So regardless of how the income rolls in, all telecoms face a common challenge. Just like other organizations, they face the challenge of churn. Now, you'll recall from your reading that churn occurs when a customer cancels their services and move to another provider. Reasons for this vary. They include, in our field, network issues, distribution characteristics, service variability, price. There are a lot of factors that go into it. Um, Reducing churn is one of the fastest ways a telecom can improve the financial results. Typically, studies show that 15 to 60% of a telecom's customer base might move to a different provider. Churn rates for pay-as-you-go plans are often much higher than that even. So offsetting the loss is kind of a happy counterforce. Every other company is losing customers at an equivalent rate. So as long as the churn rates remain in equilibrium, a new customer acquisition generally remains constant. Every telco maintains a fairly stable market share. And this is important because what we have to understand is before the Judge Green ruling in the late 80s, mid 80s, um, there was like a phone company. And now, when a customer has a bad experience with their service, they don't like to call and get a message that says to get a repair might take up to a week. They'll simply make another phone call and get a different phone company. Hey, can I get somebody out today? Yes, you can. There are choices. And so market segregation and churn rates, these things are a much, much bigger deal. And market analysis, network analysis, this science has really grown within the telecoms. So let's talk about social network analysis. We've touched on it, and I want to bring that into the forefront a little more. So, on one hand, it is true that in aggregate, people tend to exhibit what we'll call common behaviors. External factors have an influence, and unfortunately, they rarely represent raw transactional data. So, understanding these interactions, it's important to perform social network analysis, or SNA. And it's often been said that, for example, banks and other financial institutions have an idea what you're worth. Retailers know what you like to do on a day to day basis. So, content and search providers are interested in what you're doing. That's why we do what we do in web analytics. The hidden strength in telecommunications is they know whom you know. So, to connect people who want to talk or message each other, the telco needs to know the originating and receiving parties. In aggregate and over time, this transactional data maps out social relationships across entire countries and across continents. And one of the most interesting things about the social map is that it's not only customers, but also people who aren't even subscribers to that service, which is often termed as off network. So you would think that, and you'd probably be right by saying telecoms have the best social network analysis models in the world. Given that unique perspective, it's not uncommon for a market leading telecom to have the visibility over the majority of, if not all, of the originating and destinating numbers across a country. Now, while they may only be legally able to retain information about currently subscribing customers, they may still be able to visualize and explore the country's social graph in terms of location and that kind of thing. So when they combine that data with business analytics, it does create a unique opportunity. The power of analytics in this level, it cannot be understated. Given a destination number with no associated customer data, it's still possible to determine factors like their likely age within a few years based on relationships, calling patterns, message choices. For example, how often the SMS versus voice call. So that's just something to think about in terms of network analysis in the telecom industry and how it is different from others. So that's just one facet of business intelligence. Now let's talk a little bit about the business intelligence outlook. I've got some information here that's a few years old, but it's still helpful to give us a picture of what the job outlook is like and what we're studying. Let's take a look at what the predictions by 2026 are. One study that's about a year old at this point anticipates a 14% increase by 2026. I think the number is actually a little higher, but that's one of the most recent studies. Overall needs in 2020 increased 28%. And the good news, graduate degrees, not necessarily needed. I'm going to pause right here on a sidebar and just let you know that I have a terminal level degree, and I've personally been passed up for jobs by people who do not have a master's degree simply because they have certain certifications. So job certs are important as well. So keep your eye open for any opportunity for training, free or low cost, even uh, just because HR people love certifications. That's the newest buzzword, and it can help a lot. Many business intelligence positions pay well too, often starting out at six figures. That's the entry level, which is crazy. It's crazy, crazy. So, job outlook is good, the money's good, and I wanted to share with you some certification. Oops, sorry about that. Did not mean to go that far. Here's what I'm trying to show you certification sources. This is just a handful that I dug up, places you can get certs for free or low cost. One of them is Business Intelligence Free Training. The top one courses provide certification that are not necessarily Microsoft sanctioned, but they do have really good concepts. They average 2 to 3 hours. And if you bounce over to allison.com, you can spend an evening, knock out a certification, add that to your resume. Here's another one below that, EDX. Uh, it takes 6 weeks, 6 to 8 hours per week, and some of them are free, some are about $50, not too bad. And you got some Power BI training directly from Microsoft, and then there's some Excel data sets that can be used in Power BI just for exploring and checking it out. And as I come across more sources, I like to share them with you. So I'm always seeing things and sharing them and letting you guys know about it because there's constantly sources of web training, online training, oftentimes that are free, that companies offer just to promote their products, and they'll provide you with a certification at the end of that, even if it's not necessarily quote unquote A plus or Cisco certifications, but you can get certs in Tableau and SAS and other things that are within our industry that can help you out and look good on the resume. Excuse me, the resume. So that's just some examples there, and I hope you find that helpful. I'll be sharing this with you in the upload. And I wanted to share business intelligence tools with you in a way that we can use to model the coronavirus. So I've got some data that we're using that's a little bit old now because at this point the coronavirus has, the data has changed since this study was originally done, but we're going to use this anyway, just because I'm too lazy to go online and get the newest data. But I want to share with you the S.I.R model. It's a famous model. It actually predates the coronavirus. It was built to study other virus tracking situations, and it is basically centered around three variables: the susceptible population, the infectious population, and the recovered population. And as you change those different factors, you get different outputs and different charts on how long you can expect the general population to be infected. And it's not perfect because with just those three variables, you don't get a lot of information about how people behave, whether or not they remain socially distant, whether or not they get inoculated, that kind of thing. Now, you can build a more complex model, but we'll talk about that. First, I'll just show you what we have here. Let's take a look at Python. What we'll do is I'm just going to kind of cruise through some of that information and show you what we got, and I'll share the code with you. Some of you have indicated that you've got some Python experience, and so if you're interested in this, you'll be able to build a model yourself and change some of the parameters and see what kind of output you get as well. And this model is interesting and maybe a little bit scary for some. Anyway, let's take a look at it. The S.I.R model. First thing we do on any model is you want to import libraries. So I'm going to go ahead and import NumPy. Import NumPy as NP. Helps if you spell right. And I'm going to go ahead and import a couple more things here. I'm just going to grab them from a template. We'll copy it and paste it. And let me take a look and see how we're doing on time. Doing really good. Okay. All right. Once you have the libraries imported, we can start dealing with the assumptions. First thing we'll do is we'll set up our N. So we have a total population of N. I'll just go ahead and set up a comment. Population N. And a comment in Python is basically you put a hashtag up and you can say whatever you want to say. And commenting is so important because anytime you've got a lot of work going on in scripting, somebody might come behind you and do some changes, and if they don't understand what you did, it's going to be very frustrating for everyone. All right, so I'm going to set up N, let's say N equals, and I will use 1,500 because we're just going to say maybe it's a small town or a large building or something like that. And this is about an outbreak that involves various inputs. We're going to talk now about initial, the initial number of infected and recovered individuals, and it should be 0. And I'll go ahead and do that in one line. So I sub 0, which is the initial infected, and R sub 0 equals the initial infected. Actually, there's going to be 1 because one person will come into the population and screw things up for everybody else. And then the initial recovered is going to be 0. So far, so good. And everyone else is susceptible to the infection initially. So what we're going to do is say the initial susceptible is S sub 0, and we will use the N value and subtract the I sub 0 and R sub 0. So let's do that. We'll just set that up as S0 equals N minus I sub 0, oops, minus R sub 0. All right. The next part is the part that you can also play with contact rate, beta, and the mean recovery rate, which is gamma. So beta and gamma, and they're generally numbers that are pretty low, and they're expressed as a decimal point. So the beta is usually something low, less than 1, we'll say 0.2 or 0.3. And the recovery rate is over a number of days, like one person every so many days. And what I like to do is go ahead and put them in one line as well. We're going to say beta, gamma equals, and we'll say beta is 0.2, and the gamma is 1 person for every 2 weeks, 14 days. It takes about 2 weeks to recover from the coronavirus, depending on who you talk to. And we can play with that and see. And I'm going to go ahead and grid this out in points of days. We'll set it to T for time. Time equals np.linespace 0, and we'll set it to a 320 by 320 grid, 320 days. And that can be changed as well. And I'm just going to start copying and pasting some stuff. The S.I.R model differential equations. This is where we're very thankful for algorithms and useful information that we can just build into the system and not have to do the math ourselves. Let's go ahead and start that process. We'll copy that, paste it in. All right, and next we're going to set up the instructions to plot the data on 3 separate curves. The S for the susceptible, the I for infected, R for recovery, all in terms of time. And it should set it up and provide a clear picture, assuming I typed all this correctly earlier. All right, and there is that. Let me see if I can get the plot to show a little bit more clearly for you. Get this down here. All right, so you can see the blue is susceptible. Here, it's kind of hard to see because it started way up high. And over time, over the time period of days, the susceptible population supposedly would go down from 1,500 down, okay? And the infected started at 1 person, and it's supposed to have pegged out at, remember, this is in scales of 1,000, so should have pegged out in 400 people for every 1,000, and then leveled out. And then recovered with immunity. Well, that still hasn't happened in this model. It went up into the thousands, and it kind of went off the charts, so it didn't really quite fit. The thing is, the coronavirus doesn't really behave quite like the flu and things like that, so this isn't the best model, but it's a good baseline to jump off from. And something that I like to do is play with the initial individual beta and gamma numbers. So if we went back and looked at that, back up here, remember we set up as the beta as 0.2, and the beta was basically the contact rate. It's probably a little bit higher than that. So what I'm going to do is change that to a little bit higher number. Let's make it a 0.4, and recovery will make that a little bit longer. I'll say 3 weeks. And extend the days from 320 to, let's make it 365 just for a whole year. Now I'm going to copy that information out and rerun the simulation. Okay, now let's see if I can Get your plot to show up here. Now it's a little bit more realistic. Now the infected went much higher. It went to, out of 1,500 people, close to 900, and then dropped off. Now, this also assumes that every person stayed 6 feet apart and everyone, washed their hands and everything was in a perfect world. And so in the real world, obviously it didn't work like this. If it had worked like this, then the virus would have ended in a year, but we all know how that worked out. So this is just an interesting way to take the data analytics tools that we have at our disposal that are completely free and stuff that you learn in school, and apply it in a real world situation with data sets. So we downloaded actually from the CDC. So they're freely available to you. You can also go to data.gov and Kaggle and other places that provide the data. So whenever you're watching the news and they provide you with information and show you charts about how a virus is being tracked, take it at face value and go to the websites for data.gov and the CDC, in the WHO organization, WHO, and download those data sets in a CSV format and perform those investigations yourself. You can use Excel, and there's a lot of great built-in tools there. And if you are moderately familiar with Python, there's lots of great templates online to use and build timelines like the one I just showed you. That was mostly from a couple of examples that I kind of Frankenstein together online and made a few changes. But that's just something that you can do as an example of discrete modeling, rather, with the business intelligence tools. It's not always just about money and saving time and resources. It can be about plotting out things like that, which are really helpful, because what we do is useful in any industry. Like I've said before, and we'll keep saying until I retire, is that what we're learning here, what we're teaching is so critical, because we can literally use it in any industry: Department of Defense, medicine, telecom, whatever. And there's no industry that is not touched now by web analytics, data analytics, business intelligence. So you guys are in a good place. You're learning a great skill. And I hope that this is informative and interesting for you and engaging. So if you have questions about it, you want more information, if you want to see something else on your wish list, let me know. Shoot me a message at dax.bradley@rasmussen.edu, or send me a call or text at 252-458-7176. And that's it for this week. I will talk to you guys again in week 6. And we are at the halfway point now of your 11-week journey. I hope that everyone is on at least Module 3. You should be looking at 3 or 4 at this point. And if you have any questions about that, let me know. And we will be talking more about that next week. Everybody have a great rest of the week. Have a great weekend. Stay safe out there. And we'll talk to you again soon. Take care. Dr. Dax out.